We studied that we have a sender and a receiver here. The sender has an encoder and receiver has a decoder. Now we will study here how this encoder will work, how actually it will perform the operation. Then we are also studying how the decoder performs its operations. Okay, for that one, first we will study about encoder. Now this diagram shows how actually the encoding works. Now we consider here the data as k number of bits and the code word is size is n. So I have to augmented n minus k bits to this data word before any encoding process. In my example, the k size is 4 bits and the n size is 7 bits. That is, code word is 7 bits and data is 4 bits. So I have to add 3 additional bits to this data. That is called as augmenting. I am augmenting 3 zeros to this data word. Now I have a one divisor here, that is 1011. This divisor is actually agreed by both sender and receiver. That means both encoder and decoder uses the same divisor. Now using this divisor, I have to do some modulo 2 division, binary division on this value. What is the meaning of binary 2 division, modulo binary 2 division? It's a XOR operation on these bits. How actually it will works, how the modulo 2 binary division works, I will explain with some example here. Now see here, if we have 2 bits and 2 bits are of same bit type, for example 1 1 or 0 0, its output is always 0. If the bits are different, for example 1 0 or 0 1, in this case the output is 1. Now see, when the both bits are same, in that case output is 0, and when both bits are different, its output is 1. This is called as modulo 2 division. Now see this example here. When 1 1 is there, its output is 0. When 0 1 is there, its output is actually 1. Here also 0 0, here also 0. And this is also 1 1, here also 0. Now see, when you do the modulo 2 division, it's return 1 bit less here. For example, 4 bits are there, it is 3 bits here. Okay, now I have to add one more bit here for next division. In this way, we are doing the modulo 2 division. Now see, now I have to divide this data and augmented bits using this divisor. How actually the division will done, I will explain with this division table. Now first I have to divide the first 4 bits of this data with this divisor, because here also 4 bit, I have to select 4 bits. So it will look like this way. Now I have to do the XOR operation here. Okay, now the result is here. Sorry, here first I have to write the quotient 1, because the division is possible. I can divide this value with this divide value, so quotient is 1. Okay, now the result will be 3 bits here. When you divide it, you got the 3 bits. Now in next step, I have to pull down this 0 here, like this way. I have to pull down this 0 here. Now I have to divide again, but the first bit of this one is 1 and the first bit of here it is 0. So I cannot divide when the first bit is here 0 here. So I have to XOR this one, I have to divide this by 0. So I have to divide this by 0 here and I have to write the quotient 0 here. When I cannot divide it by this divisor, I have to put it here 0 as the quotient and I have to divide it with 0. Now whenever you divide it, you got the result 100. Now I have to pull down this next 0 here. Once it is pulled down here, I have to divide it again here using the divisor. Now I can divide because here also 1, the first bit also 1, so I can divide. So I have to divide it with like this way. Now I have to put it here quotient 1. Then the XOR operation of this one will be 0 1 1. So I have to pull down the next bit here. Next bit I have to pull down. So I cannot divide this again because it's again 0 here and here it is 1. I cannot divide it, so I write it here 0 here. Okay, now this is a 0 division. Now I have to write it here 0. Okay, now this is the answer quotient value I got. Now what is the remainder here? That is important part here. This is quotient is not the important here. The important part is remainder. So what is the remainder? 1 1 0. This is the redundant bits. Okay, this is the redundant bits. I have to add it to the data. Whenever you divide it here, you got the remainder. The remainder is nothing but the redundant bits. I have to add it to the data. This is called as code word. Now I done the same process in this diagram here. Okay, I will divide it and got the remainder. This remainder is added to the data word and create a code word. When the division is not possible, I have to divide it with 0.